Hi everyone, my name is Zhao Dan, and please let me introduce the methodology part of our project. First, we describe the dataset. We use Kelly-Parkinson CSV here. There are more than 5,000 observations with 22 attributes, and 42 patients participated in this data collection activity, and all of them are from 36 years old to 85 years old. And here, there are 65% of them are male and 35% of them are female. The target in this dataset is quite clear. It is the total UPDRS, and the main aim of the experiment is to use other attributes to predict the total UPDRS. And here we discovered that 90% of the data in the dataset are numerical data, and only 10% of them are categorical data. And then we treated the data. First, we handled the missing value. For the total UPDRS, there are more than 11% missing values, so that we decided to drop them. But for the NHR, there are only about 7% of them are missing values, so that we replace the missing value with the median of this attribute. And then the outliers, we detected the outliers by using the interquantile range, and all of the data that out of the upper and lower bound will be removed. And here we also normalize the features, all the numerical features, because some of them are of different scales, and after normalization, all of the numerical features will be ranged from 0 to 1. And then we explored the data. First, we conducted the univariate analysis. In this analysis, we discovered that 13 out of the 16 voice measures have right-skewed distribution. However, we don't want to see right-skewed distribution in our experiment. Therefore, we use log transformation to transmit the right-skewed distribution to normal distribution. After that, we also conducted a bivariate analysis. First, we analyzed the numerical features. Here, we listed the top 11 correlations between the features and the target. But should we cover all these features in our feature set? We discovered that some of them are quite familiar. For example, like here, shimmer APQ11, shimmer DB, jitter percent, and jitter PPQ5. Therefore, we calculate the correlation within the jitter and the shimmer group, and it is quite high. We could see here, which means that the information conveyed by these two groups are quite similar. Therefore, we decided to pick the highest value from the group respectively. So here for shimmer, we pick the shimmer APQ11. For jitter, we pick jitter percent. And then after that, we also want to know that what kind of regression relationship between the target and the feature sets. Therefore, we scatter plotted the linear model and the non-linear model. We discovered that non-linear model performs much better than the linear model. After exploring the numerical data, we come to the categorical data. Here, we discovered that the p-value of the attribute sex is lower than the significant level 0.05, which means that we should include the attribute sex in our feature set. And then, all of the attributes picked from the dataset, along with the targets, were listed in this table. Finally, we got some very interesting insights. First is the most relevant numerical features is age, and we also need to highlight that the numerical features have non-linear relationship with the target. Okay, that's all. Thanks for listening.